For example 2, I went ahead and I factored f of x, but before I cancel any factors, what I want to do is I want to check the domain, because I want to check for any possible vertical asymptotes. Okay, so the domain is all real numbers x such that x cannot equal whatever makes the denominator equal to 0. So we can see, hopefully clearly see, that x cannot equal -2 and x cannot equal +4. And so these are the two now in the playoffs for the vertical asymptote prize. And if they survive the canceling round, then they can make it all the way to the vertical asymptote. So if we take a look here at the numerator and denominator factored, we can see that we can cancel the x plus 2's. Okay, when we cancel the x plus 2's, that means that when x is equal to 4, x equals 4, actually x equals 4 is the vertical asymptote because it does survive. Okay, and then the horizontal asymptote, might as well look at that now, the same size bubble over same size bubble. That would be, I probably shouldn't write it like that. I'll just say same size bubble over same size bubble. So then y equaling, excuse me, y equals the coefficients of the x squared terms. So it's 1 over 1, so y equals 1. And then let's see here. What else do we need? We need the intercepts, and the intercepts would be, let's start with the x-intercept. Whatever makes the numerator equal to 0. That would be when x minus 2 is equal to 0, and that would be when x is equal to 2. So when x is equal to 2, we have an x-intercept. Okay, and then the y-intercept would be f of 0. So when x is equal to 0, we get 0 minus 2 over 0 minus 4, and that would be 1/2. Okay, so we have a y-intercept. So we have x-intercept, y-intercept, and then what else do we need? We need to know where the holes are. And that factor that got canceled early on, that x plus 2, that 4, let's do it this way. In the domain, these are the ones that, these are the numbers that possibly could be vertical asymptotes. So the 4 gets it, but the 2, or the -2, comes over here, and there's a hole when x is equal to -2. Okay, and because you still can't, the function still cannot be defined when x is equal to -2. And so what does that look like? In a rational function, any values in the domain, any x values in the domain, are either going to cause the function to have a vertical asymptote there, or it's going to be a hole. In other words, the restricted x values in the domain. So that's what I should say it like that. So the domain is all real numbers x. Okay, so for any real number in the domain, you can't have a hole or a vertical asymptote. So again, the only possible behavior of the graph at these restrictions on the domain, so let me write that down also here. These are restrictions. The restrictions are at x equals -2 and at x equals 4. So restrictions in the domain will either lead to a vertical asymptote or a hole. Okay? We already got the vertical asymptote and we know where the hole is. And then when we replace x with -2, that gives us where the hole is. So f of -2 is equal to -2 minus 2, or -4, over -2 minus 4, or -6. So we can see the hole has a y-coordinate of 4/6, or 2/3, and so we're going to put that right here, 2 over 3. So we know where the hole is, we know where the vertical and horizontal asymptotes are, we know where the intercepts are, and we can go ahead and now draw the graph of the function, because we've got all the information we need to be successful at drawing the graph of the function. Okay, so let's draw the horizontal asymptote, y equals 1. Okay, there's y equals 1. Actually, I probably shouldn't do that. I don't know how busy this graph is going to get, so I don't want to add anything more that I don't need there. Okay, so 1, 2, 3 there, and so we can clearly see that y equals 1 is the vertical asymptote, and then we know that x equals 4 is the horizontal, or I think I just said vertical. So the y equals 1 is the horizontal asymptote. The x equals 4 is the vertical asymptote. Okay, and then let's add the intercepts. So we have x equals 2 is the x-intercept. We have y equals 1/2. This looks more like it. Is the y-intercept. And anything else? Oh yeah, we have a hole at -2, 2/3. Okay, so 1, 2, -2, 2/3. So we have a hole right there. Now that lines up nicely. Okay, lines up nicely, and so we're just going to go ahead and draw the graph. Right through the hole, right through the y-intercept, right through the x-intercept, and the only way it's going to look, the only way it could possibly look is like that, because behavior near vertical asymptotes, I think I may have mentioned this in the last video, always behavior is either going to be the y values are going down towards negative infinity or up towards positive infinity. And if you wanted to put plot some points, you can plot some, or make an XY chart and take a look at the Y values as the X values are getting closer and closer to 4 from the left hand side, so like 3.5, 3.7, 3.9, 3.99, and you can see that the Y values are actually getting smaller. Okay, but understanding the behavior of rational functions near vertical asymptotes will help us not need to do the XY chart. Okay, so let me erase these arrows. And then again, we have on the right side of the vertical asymptote, we can see that we would have a graph always either looking like that or like that. Okay, so the two curves that I just drew, it's either going to it's going to be above the horizontal and to the right of the vertical, or it's going to be to the right of the vertical and below the horizontal. But remember, we don't have any more x-intercepts, so it can't be the one on the bottom. Okay, so if it can't be the one on the bottom, it must be the one on the top. The other thing that could help you here is to remember, it's like, well, why do we have anything over there? Well, the reason why we have anything over there is because the domain, we know that the domain is all real numbers except for this real number of -2 and this real number of +4. So the graph has to be somewhere other than at those two values. Okay, and we can see clearly here, looking at the current graph, that the graph is accounted for every single x value besides -2 and +4. So there you go. There is your example 2, and I'm not sure if in the most recent video if I also told you to do this one. So just in case I didn't do that, then go ahead and do this one here. Analyze the graph of this function. And then that's it. That, and then the Google form. There's I think 4 multiple choice questions that I'm asking you to do, and then fill out those answers on the Google form. You don't have to print out the questions, you just have to answer the questions on the Google form. Okay, so I'll see you in class.